Kia ora everyone. I'm going to go through the TGC Derived Grade Exam Level 3 Chemistry Organic paper. Each question is going to be done in a separate video. And it's not going to be posted until all of the resets are done. And if you come from another school, you should see that it's different enough that you shouldn't get an advantage if you haven't done your derived grade exams yet. Okay, let's start. So the first question is our pretty standard naming and drawing. There's nothing too tricky in this. You just have to take care. So 1, 2, 3, 4, 5, 6 carbons in the main chain, giving us a hex. This functional group, acyl chloride, so hexanoyl chloride. The trickiest bit we seem to find is in the two methyl groups. They're both off carbon 3, but we need to give them each a number. So it should have been 3,3 dimethyl hexanoyl chloride. Ethyl butanoate is an ester. And we need to remember that the anoate bit is the bit connected to the C double bond to O, and the ethyl bit is the bit connected to the single O. So I always start with the C double bond to O, which must have 4 carbons. 1, 2, 3, 4. I'm not going to draw all my H's in it, it'll just take me too long. And then the ethyl bit, make sure I've got my ester functional group, and then 2 carbons off that with all the hydrogens. Don't forget, you must draw your hydrogens in your examinations. And don't forget, you should be able to identify an ester functional group there. Okay, this one has 3 carbons, so it's a prop. This functional group is an aldehyde, and aldehydes must be on carbon 1, so we do not need to number them. And I have a chloro, which is therefore off carbon 2. So that's 2 chloropropanol, no numbers or you'll get that wrong. And pentanamide, pent for 5. And anamide is our C double bond to O, NH2. And let's just put in where the hydrogens would go, just like that. This was a pretty generous 2 correct out of 4 to get an achieved. This one was a bit trickier. So with most chemistry, my suggestion is that you get the equations and the definitions right first and then use that to help you answer the actual question. So here we've got permanganate, acidified permanganate, which is an oxidant. This provided a bit of an issue. This is Tollens, which is a weak oxidant. And this is what Tollens is. It is ammoniacal silver. So some people got really confused and thought there was like 3 different things or 2 different things reacting here. No, you kind of have to know that Tollens is this. So this question was about a strong oxidant versus a weak oxidant. So the strong oxidant will oxidize the aldehyde to the carboxylic acid and the secondary alcohol to a ketone. So 1, 2, 3, 4, 5 carbons. This carbon oxidized by adding an extra bond between a carbon and an oxygen, and this one oxidized by adding in an extra oxygen. And then just add in all of our hydrogens. Those of you who like condensed structural formula, just be really careful where you put H's. Here's our weak oxidant. So this will only oxidize an aldehyde, not a secondary alcohol. So we still have 5 carbons. This one still gets oxidized to a carboxylic acid, but this one does not change the alcohol. Oops, let me see. Okay, don't forget to put your H's in. So that's the first bit of this question. If we can get this right, then this becomes easy. Most people struggled because they couldn't work this out. Don't forget too, I promise that you have had the chance to learn everything you need in class this year. So you need to search your brain and don't make up weird things in your answers. So compare and contrast the 2 reactions. So basically, strong oxidant, weak oxidant. Type of reaction, oxidation. A description of the changes observed. So this is what we would see. purple to colourless in this one, colourless to silver mirror for Tollens. And the reasons for the differences is simply that the weak oxidant does not oxidize alcohols, whereas the strong oxidant does. So once you've got this right, then you can just pretty much put into words what your equations show you. It's a pretty standard technique for doing well in chemistry. Last part, I think, hang on. Oh, here no. Last proper part of this question. So this is a two-step equation, and it's actually a pretty tricky level 2 question. So as soon as we see the double bond, we know it's probably going to be addition, where we break that double bond and we add two new things, one to each double bonded carbon. And in this case, we're going to add an H and a Cl. So we need to do that first before we can figure out what happens here. It does say there are two possible products, and give a reason for the two possible products and explain why the resulting product is the one most likely to be formed. So that's implying that this is going to be the major. So when we're stepping through this, we want the major product in here. So let's draw our main chain. 1, 2, 3, 4, 5. Okay, let's keep our CH3, our CH3. And then we're going to break this double bond. Got two extra spaces there. And what we want to do here is we want to add the hydrogen to the double bonded carbon that already has the most hydrogens. So if we look here, this is carbon 1, carbon 2 and carbon 3. Carbon 2 has 2 hydrogens, carbon 3 doesn't have any, so this is the richer carbon. So this is going to get another hydrogen, this is going to get the Cl. Okay, so now we've got our major product. What's happening as we go from here to here? As soon as we are forming a double bond, we know this is going to be elimination. Elimination is removing the functional group and a hydrogen from, oh, I didn't draw that H in, from an adjacent carbon. So one of these two hydrogens. So this elimination, it's not eliminating water, that would be conc H2SO4, the dehydrator, but this therefore is going to be KOH alk. All right, so now we have to do a bit of explaining. So we need to give a reason for two different products. So why are there two different products? And explain why this product and this product are the major products. So to start with, let's call this reaction 1 and reaction 2. So reaction 1 is our addition. I need to define it. So an addition reaction is when I break the carbon to carbon double bond and I add two new atoms or atom groups, one to each previously double bonded carbon. Right, so there's my addition. So why is this the major product? So the major product forms, and we need to be careful here because there was a lot of vague waffle that went on in the exam, and I know it's stressful, but just add in that little bit of certainty. So the major product forms when the double bonded carbon, a lot of you just said the carbon, there's lots of carbons in here, the double bonded carbon with more H's to start with, gained another H. So as we said before, carbon 2 had one H, carbon 3 had no H's, therefore the major product formed when carbon 2 gained another hydrogen. Right, so that's shown here, the major product. Just a little note, some of you numbered your carbons, which is great, but you're probably best to number them how you would number them if you were actually naming this. So that would be carbon 1, that would be carbon 2 and carbon 3. Otherwise it gets a little bit confusing. Okay, now why could we form a major product here? We haven't really addressed that. That's because this double bond is asymmetrical. Those two double bonded carbons are different, and we are adding an asymmetrical reagent or two different atoms. So we need to say that. So asymmetric alkene and reagent gives us two products, a major and a minor. Okay. Right, that's half of the question done. Second half of the question, let's define elimination. So elimination is where we remove the functional group, in this case Cl, and a hydrogen from an adjacent carbon. So that word adjacent is quite important in elimination. And we form a C double bond to C in their place. Now, again, we have an asymmetric haloalkane. Here is the carbon with the functional group, and it's got two adjacent carbons which are different. This adjacent carbon has two hydrogens. This adjacent carbon has one hydrogen. So when we're doing elimination, the major product forms between the carbon with the functional group and the adjacent carbon with fewer hydrogens. That's the pore gets poorer. I'm just going to turn the page over. Right, so, sorry. The haloalkane is asymmetric, which means two products can form. Oops. And the major is the one formed when the Cl and the hydrogen from the adjacent carbon with fewer hydrogens is removed to form the double bond. It's a lot of work in that question, but it technically is level 2. You just have to learn to be really clear with your language. Now this was a nasty question, and in fact I'm not even really going to go through it because we decided to ignore it. Just well done for those of you who redrew this functional group like this and then saw the condensation to form the CONH, blah, blah, blah. And I think this was just a badly worded question. We didn't look at it clearly enough because what they're saying is that another one of those would have made a condensation with that. But I think if we'd wanted you to put that down, we would have put that there was 2 of those for every one of those, or something like that, to indicate that that's what you should have looked at. And then, of course, in here, your bromine would have added across this double bond. Don't worry about that. It's a crap question. We ignored it, so we just marked it out of the rest of the paper. Although I gave achieved marks for getting parts of this right if that helped you get a better grade. So that's the end of question 1. Kia pai tō rā. Hope you're having a great day. See you soon.